Hello and welcome again. Today we're going to be talking about process variables. The first process variable that we're going to talk about is mass, and it is denoted with the letter M. And you have conversions between different systems. The international system uses kilograms, but you also have grams, and you have in English system the pound mass. So you also have metric tons, ounce, etc. Right? So if you want to turn this mass, for instance, 400 grams, you want to turn it into pound mass, what you have to do is use these conversions. And you state that 400 grams, well, you state that 1 kilogram is 1,000 grams, so gram will cancel with gram. And then from kilogram, you can go to pound mass with this conversion, 2.2. So you can cancel out kilogram with kilogram, and then you have 0.88 pound mass. You can also use the fact that 1 pound mass is 453.593 grams. So you can divide and obtain 0.88 pound mass as well. Sometimes you don't want mass, but you want the mass flow. And the mass flow is the amount of mass that is passing through a pipe or any given flow system. And this is the amount of mass per unit time. You denote this with an M with a point here. And this is mass per time. And if you want to turn these 400 grams per second, let's say, you can turn it into pound mass per minute. Well, you use the same conversion factor from gram to pound, and then you just state that 1 minute is 60 seconds, so that second will cancel with second, and you will get the minute here. And also very related with mass is weight. With the letter W, this is a force. You have seen this in physics. Weight equals mass times gravity, where the gravity is 9.81 meters per second square, or 32.174 foot per second square. Now, seeing these units that 1 Newton is 1 kilogram times mass per second squared, but if you want the pound force, then you don't have that 1 pound force is 1 pound mass times foot per second squared, but you have that 1 pound force is 32.174 pound mass times foot per second squared. And this is very related with gravity, right? So if you want to do a conversion, well, the 400 grams that we have, you turn them into kilograms, as we have already seen, 0.4 kilograms you will have, you multiply times the gravity, 9.81, and then you just state that 1 kilogram times mass per second squared is 1 Newton. You will have 3.9 to 3.924 Newton. But if you want this in pound force, well, you can turn this Newton to pound force using the 0.22481. But you can also have that 0.88 pound mass. You multiply times the gravity, 32.174 foot per second square. But then you have to state that 32.174 pound mass foot per second square is 1 pound force. So you can actually see that 1 pound mass equals 1 pound force. And then you have the mole with the letter N. This is the amount of substance. And 1 mole of particles such as atoms, as molecules, or you can say 1 mole of oxygen, 1 mole of the molecule methane, I don't know. This has 6.022 times 10 to the 23 particles, which means this is Avogadro's number. It's denoted with capital letter N with a subindex A. And this is related to mass through the atomic mass or molecular mass, the mass per unit of mole. So the mass is going to be equal to the molecular mass times the number of moles. The atomic mass can be found in the periodic table. So for oxygen, you have 16, for carbon, you have 12, for chlorine, you have 35.5. And if you have a molecule, then you have to multiply the number of atoms that it has. Let's say that you have the molecule O2, which is oxygen, and you have 2 times 16, this yields to 32. 32 atomic mass units, which is also 32 gram per unit mole, or kilogram per kilogram mole or kilomole, or 32 pound mass per pound mole. And if you want to get the number of moles, let's say you have 400 grams of oxygen, you just divide over the 32 grams per mole, canceling grams with grams, and you will have the 12.5 mole of oxygen. Also very important, you have the volume, and you are acquainted with the cubic meter and the liters. In English system, you have cubic foot. You also have imperial gallons, right? So this is the amount of space that is going to be occupying certain mass, right? And there are three types of volume. The volumetric flow is V with a point, is the amount of volume per unit time. I don't know, cubic meter per second, something like that. The molar volume is the amount of volume per unit mole, and the specific volume is the amount of volume per unit mass. So you will have the volume and this volume over mass. You can turn it into a number of moles times a molecular weight. So this will yield to an expression where the specific volume is related with the molar volume through the atomic mass or the molecular mass, right? And the density is the relationship between mass and volume. This is mass per unit volume. I don't know, cubic meter per kilogram. But if you see in the previous that this is volume over mass, then the density is the inverse of the specific volume. And very important, it only applies for pure liquid water at the standard conditions that the density is 1 gram per milliliter or 1,000 kilograms per cubic meter, which is the same as 62.4 pound mass per cubic foot. Never assume that 1 milliliter is 1 gram as if it is a conversion, or that there is a conversion factor from volume to mass. This is the density. And this is a common mistake. You always say that 1 milliliter is 1 gram, and this does not really apply at all, only if it is pure liquid water at standard conditions. And sometimes instead of having the density reported, you will have the specific gravity, which is the density of any substance relative to the density of water. And a specific gravity reported of 0.78 will yield to a density of 0.78 grams per milliliter or 780 kilograms per cubic meter or 48.7 pounds per cubic feet. And in order to measure the flow, the volumetric flow, we use what we call a flow meter or a rotameter. You have a fluid, let's say a liquid or a gas, going into this flow meter, and then you have some indicator. It can be something like this, or it can be sphere. And the more the flow, the more this will go upwards. So this is calibrated. You have here a lecture of liter per minute. And if the flow goes down, this guy will go down. And this is something that is used in industry. So we have seen process variables in this video, mass, volume. Also, we have seen the weight, right? But in the next video, we're going to be looking at more process variables.